Okay, this review is from the homework that was labeled 3A. Let's see, I want to go over question number 6, and let's see, this question, I don't think it was labeled as number 6, but you had a question in the homework like this, where we're looking at an orthovoltage beam with a half value layer of 2 millimeters of copper, and we want to know what percentage of the beam is transmitted through 8 millimeters. So this is similar to the question in the question number 3 homework. However, we can take a shortcut here if we just use the principles of half value layers, remember? So one half value layer gives you 50% transmission, 2, 25, 3, 12.25, and so on and so forth. So the issue is now, if one half value layer is 2 millimeters, how many half value layers is 8 millimeters? Well, we can figure this out. This is simple math, right? So 8 millimeters is 4 of these. So this is 4 half value layers. So we can use that principle in 1, 2, 3, 4 and get to 6.125. That's what this should be, percent, or 6.25%. Or we could write on this side, this is 2 millimeters, this is 4 millimeters, this is 6 millimeters, this is 8 millimeters. There we are. So it should be 6.25 or more. And the reason it says or more, because we were talking about in class how when you add a half value layer or some material between these packets of energy or the beam, what happens is the beam gets a little harder, especially when we're talking about low energy beams. So the amount of half value layers, or the thickness of half value layers required after you add half value layers, actually decreases. So you're actually going to probably get a little bit more than 6.25%, but this is the correct answer. Okay, there's another question in